Anything else? Difference between ARP table and MAC address table. Anything else?
In ARP table, there is a target IP, then a target MAC. Target MAC is unknown. And MAC address is for the MAC address of that PC, sir.
CAM table contain the IP address and the interface that take you to that.
First of all, tell me
address.
which device will maintain MAC address table and which device will maintain ARP table.
ARP table maintained by the router, MAC address table by the switch.
ARP table maintained by every device.
PC sir, any device. ARP table and MAC address table, switch.
Means ARP table will be maintained by switch also?
Yes.
No sir.
Yes.
If it's an L3 switch.
If it is L3 switch. You should say that any device where we can configure the IP address, right? Because what we discussed, that when we assign IP address on the Ethernet port, device start maintaining ARP table, right? And in the ARP table, what information it will store? In the ARP table?
Target IP, sir. Target
MAC address against IP.
Source IP, sir.
Address and IP address.
Some people are saying source IP. Is it true? Right?
No.
Source IP.
So connected devices.
Connected device. Someone is saying source IP, someone is saying connected device. Is it true?
Network.
Sir, it is ARP is maintaining the source IP and MAC address also, so both are maintained.
Source IP and MAC address, he is saying.
So physical value and logical value, both.
Physical value and logical value.
Why didn't it in IP address?
So if it gets the reply, then it will have source and destination IP and MAC as well. So
Source IP. Source MAC.
Okay, source. There is no source, there is no source MAC, there is no connected device. I don't know what you guys are saying. Really. Because what I told you is ARP table is used to store the MAC address with IP address. Right?
Yes.
What I told you, that for an example, this PC or this router has one IP address 10.1.1.1 and their MAC address is A. It will store that information in their ARP table, that hey, my IP address is 10.1.1.1 and my MAC address is A. If this machine needs to send data to any other machine, let's say 10.1.10, so first it will check the ARP table that MAC address is available or not. In the ARP table, if MAC address is available, it can encapsulate the frame. If it is not available, it cannot send any data to 10.20. First it have to resolve MAC address, right? And where it will store that MAC address of 10.20. Again in the ARP table, 10.1.1.20 and MAC address is, let's say, B. If destination is in same network, then the destination MAC will be the MAC address of destination device. Otherwise, destination MAC will be MAC address of default gateway, right? So let's say the default gateway IP address is 10.100, right? So there will be entry of default gateway as well, that 10.1.1.100 is one IP address whose MAC address is, let's say, C. It is like that, right? Just table to store MAC address with IP address. What is the function of this ARP table? Whenever this PC need to send traffic to, let's say, 10.20, it need destination MAC, it will find from there, from the table. If this PC need to send traffic to any other subnet, right, to any IP address which belongs to different subnet, it need the MAC address of default gateway, and here is the MAC address of default gateway, right?
Yeah.
So every time to send any data, whether it is TCP data or ICMP data or IP packet or EIGRP, OSPF, HTTP, DNS, DHCP, every time machine need destination MAC and machine will look up there. ARP table. Guys, I am getting noise from somewhere. Please put yourself on mute if you are not speaking. Requesting everyone to keep yourself on mute if you are not speaking, and if there is noise. If there is no noise, no problem, you can keep yourself on unmute. And if you want to ask something, then unmute yourself and ask. So about the ARP table, when I am asking you the difference between ARP table and MAC address table, first of all, you should say ARP table will be maintained by every device where we can configure the IP address and it store MAC address with IP address. It's so simple, isn't it?
Okay, sir.
Yes.
It will be maintained by your PC also, your mobile device also, your laptop also, printer, server, router, switch, firewall, right? Every device where we can configure the IP address. And what about the MAC address table? Now MAC address table.
It will store the MAC per port of the
It
switch.
will be maintained by which device? First of all, tell me that.
Switch.
Switch.
LT switch.
Switch, or you can say L2
Layer to switch
device. Right? Earlier we were using Breeze as well, right? That was also similar to switch. All L2 devices. Because you know the L2 device forward traffic based on L2 information, based on L2 address, and L2 address is MAC address. When I am saying this device works at layer 2, it is an L2 device like layer 2 switch. It means what? It means that that device forward traffic based on layer 2 address. When I am saying router works at layer 3, it means what? It means router forward traffic based on IP address. When I am saying a firewall works at layer 4, it means that device, that firewall forward traffic based on layer 4 address, means port number. Getting my point? So
Sir,
Yes.
can you
all
explain again?
L2
Sorry.
device will maintain MAC address table. And what will be the information in MAC address table? Like in ARP table, we have seen the MAC address with IP address.
The MAC address, the port, the port,
MAC address with port number.
the switch port.
For an example, see this router. If I will check the ARP table of this device, enable, what is the command? Show IP ARP. Is there any information?
No.
No,
Not yet.
And show IP interface
not
brief.
yet.
Is there any IP address configured on this router?
No.
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 If I am going to say interface VLAN 1 and IP address 10.1.1.1 255.255.255.0. See, IP means on any interface. It can be on physical interface F fast Ethernet 0/0/0/1. It can be virtual interface like VLAN 1 interface. It can be tunnel interface. It can be IPsec interface, right? Any interface. Doesn't matter where you have configured the IP, but as soon as you will configure the IP on the device, it will start maintaining ARP table. Why there is no any information still? You can see ARP table is empty. Why? Why, guys?
No
Because
packet has been sent.
even we have configured the IP address on this interface, but this interface is still
Shut down.
administratively down, as well as their line protocol is down. So if I am going to say interface VLAN 1 and no shut on the router, no shut on the router, and now if you will show you, if I will show the ARP table, now you can see still, now I am expecting the ARP entry should be there, but show IP interface brief, still their line protocol interface is down. The line protocol should be up. Why the line protocol is down? VLAN 1. Actually, this is router here. We cannot create the VLAN 1. VLAN 1 does not exist over here. Let me do one thing. Let me try to configure one IP on the physical interface. See, if the line protocol of this virtual interface will come up in the switching, you will see that. Then it will also start maintaining ARP table. Right now, I am going to configure IP on physical interface. No shut and IP address 100.1.1 255.255.255.0 and no shutdown. Again you can see show IP ARP. There is nothing because show IP interface brief. This interface is status is up but the line protocol is down. Okay, who will tell me what is the difference between the status and protocol? When sometime you will see a status up, line protocol is up, sometime you will see a status up but line protocol is down. And this is very important for network troubleshooting, guys, very important, I must tell you. Sometime you
So,
will see
Sir,
so with the
sh-
status, it's normally when the port is actually shut down by the administratively shut down, and with the protocol, it can be a layer one issue like a cable or something might not be working somewhere.
okay, anything else? He is saying a status is the administrative mode. If administratively we have run command no shut, then it is going to be up. If administratively it is down, then it is going to be administratively down.
No.
And about the protocol, what about the other difference between a status and
I think
protocol?
status. I
It's
think
the physical
status
issue.
is layer one and protocol is layer two.
Okay, he is saying a status is layer 1 and protocol is layer 2. Okay, what about others? Difference between a
Yes,
status and protocol, simple question.
yes, status layer 1, protocol layer 2.
Layer 1, layer 2.
sir, status method was status. There is no, sir. That is a virtual interface, sir, and protocol is a physical interface, sir, like
See,
a
I'm
layer
talking
one.
about this interface, fast Ethernet 0/0. This is the physical interface. This interface
Yes,
status
sir.
is up, but their protocol is down.
Because of the here is sorry L1, I think cable is not connected another PC or another device. That's why
Yes.
it's down, sir. And
So
there is not
the state
running the any command, sir.
the status is, sir, what is the current sir, what is the current situation of this port, and the protocol is I think the set of rules. I think set of rules we have to define for that one.
Okay.
I think status, no shutdown, and protocol, if there is another connectivity with another port, can be up.
Many people are right here. Whoever are saying status is layer 1 and protocol is layer 2. You are absolutely right. Layer 1 means, see, this is administrative mode. That is also fine, right? That is also true, right? Someone said that status is the how administrator has configured the interface, and the protocol is he said, I think layer 2 connectivity, the other side connectivity, other side interface. Right? When I'm talking about the protocol means I'm talking about the layer 2. See, if the protocol is down and the status is up, that means there is some issue of
Mismatch.
Physical,
cable,
sir.
or
Yes, sir.
your port connector, right? The pin. For an example, say, let's say here I have a router 1 and router 2. You know, by default router interface is what?
Shut down.
By default router interfaces are shut down. So this interface of router 1, this is R1 and this is R2. F0/0 of router 1 and F0/0 of router 2. By default, both ports are down.
Down.
I'm talking about what? Administrative mode. By default, both are down administratively. Administrator has configured this down, right? Shutdown command is running on the particular interface. When you are going to run no shutdown command on F0/0 on router number 1, what will happen? Their status will come up, but their protocol will be still
Down.
down. Why? Because the interface which is connected to router number 2 to the neighbor device, their administrative mode is still down, right? If this interface is administratively down, then you will always find line protocol of this interface is down. Means administrator has configured this side up and this side down, right? So a status of R1 interface will be up and line protocol will be down, and a status of R2 will be down, which is already there, you can see, and their line protocol will be also down. Once I will run no set command on router number 2, that means administratively here also we have configure up, no shutdown. So their status will also come up, status will be up, and their line protocol, their neighbor device is up, so it will be up, and R1 line protocol in off will also come up. This will also come up. Means it depends on neighbor device. The connected device is up. Now, if there is any issue on the link, or maybe not only on the link, let's say duplex mismatch issue is there on the link, right? There is a loop, right? There is any error, or cable is not working, the connector is not working. Because of that, R1 F0/0 is still not able to sense R2 interface. It will be showing the protocol down. And if you have
Sir,
configured
how did it sense? I mean, like
it sends some
whenever
messages.
Okay.
You know, when your interfaces or any device, when you turn on your laptop is connected with one Ethernet cable, let's say here, right? So as soon as you will turn on your device, it will send automatically, the by default some protocols are running, right? Some kind of message, sometimes some small signal even, like to negotiate the duplex,
Like hello.
On the
Like hello.
router, like hello, yes. On the router, you know what duplex is configured by default? Duplex mode. There are three duplex. There are three duplex: simplex, half duplex, and full duplex. No, the configure mode means administrative mode is auto.
Okay.
Means it is going to negotiate from their neighbor device. How it will negotiate? By exchanging some kind of information only, right? Signal or a small message. So if there is no any message exchange, let's say on the every cable you will see there are two kind of ports. One is TX and another one is RX. TX is used to transmit the data and RX is used to receive the data. For an example, the F0/0 of R2 cable, TX port is working but RX port is not working. In that case also you will find the line protocol on router number 1 is down. It can be because of SP duplex. So what it mean? It mean if the line protocol is up, means there is layer 2 connectivity. That means layer 2 messages can be exchanged here, are already exchanged. Getting my point? Are already exchanged. See, if you want to see here on router number 1, right now the line protocol of my interface is down, F0/0. If line protocol is down, router 1 cannot send any message from this particular interface. If I am going to connect any device here, let's say one switch. If I am going to connect one switch over here, these are very important for troubleshooting, guys. Again, I am saying you are going to learn later CRC error, many things over here at layer 2. So these all will help you while troubleshooting the issues, layer 2 issues. And layer 2 issues are very common on the WAN link in the production, very common. Now if you can see even the log message, the line protocol of interface fast Ethernet 0/0 change state to up, right? Because as I have connected the switch over here, it can sense the switch and automatically it is sending some kind of traffic on the switch. Even you can check on the switch. If I will run one command here, so interface enable, so interface F0/1, and I am saying include packet. Include packet command is not working. Okay, packet, include packet, like this. You can see how many packet has out from this interface. Packet in
950.
input automatically, right? We have not configured anything. And how many messages it has sent? in last 5 minutes. Send and receive, you can see the byte of data. And how many packets are out from this interface? 2357. Now if I am going to check again after some time, you can see 2357. After some time you will see the number is increasing. Even this number you can see the input.
So are these the BPDU messages?
So many protocols are running by default.
Okay.
Right? First message which you need to learn over here is keep alive message. Keep alive message, right? What is the function of keep alive? Just to check the layer 2 connectivity that my device,
Heartbeat,
my neighbor is alive or not. By default it is running.
Okay.
Right? And some other protocols are there which we will learn here. So with the help of these kinds of messages, it can sense the protocol. If protocol is up, that means there is layer 2 connectivity. Right? And now on router number 1, as you have configured the IP and your interface line protocol is up, so IP interface brief. Now you can see F0/0 line protocol and status both are up.
Sir.
This is the admin mode, layer 1, and this is the layer 2. That means layer 2 connectivity of this particular interface is up. Means neighbor device port is also up. And now if you will check ARP table, so IP ARP, you can see they are on IP address and they are on MAC address. This is the MAC address of F0/0. So interface F0/0 include BIA. Is it the same MAC address?
Yes, sir.
So why you are saying source MAC, source IP, destination IP? Any IP address. See, if I am going to ping 10.1.1.100, it will try to resolve the MAC address of this IP address. Right? You will find this entry in the ARP table. But is there any device who is using this IP address? So
No.
IP ARP. So that's why you can see here we are not able to find, right? Sometime you will say incomplete entry. Correct? On the router we have seen that. Incomplete. This is my ARP table, and now I am talking about MAC address table. Now tell me the MAC address table. What is MAC address table? Which device will maintain? That is by layer 2 devices. Fine. What is the function of MAC address table, and how first of all tell me how devices is going to build ARP table.
By learning.
By ARP requests.
Sorry guys, you was not audible. Please speak again. How devices are going to build ARP table? Then I will ask you same question for MAC address table. Tell me first about the ARP table.
ARP request will be generated. It will be a broadcast message.
With the help of ARP protocol, right?
Yes.
With the help of dynamically. It is going to build MAC ARP table dynamically. There will be only one entry that is going to be permanent, which is on the Cisco device. You will find their on IP address and their on MAC address. That is permanent entry. It will never remove that. There is no any timer. Here on the router even, if you will see the ARP table again, once again, so IP ARP table, you can see type is, what is the type?
ARPA.
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 If on the switch, if I will configure one IP address, let's say one IP address config T interface, let's say VLAN 1 and IP address 100.1.1.10 255.255.255.0 exit and interface F0/1. Okay, no problem. And go to router now. Ping that IP address. Will ping work? If I am going to ping the SVI interface of switch which I have created, will ping work? The IP address on switch. was ping 100.1.1.10. Can I ping it?
No, it doesn't have route.
No, both are in same subnet, brother. IP address of
Okay.
F0/0 is also same. So IP interface brief. Both are in same subnet 100.1.1.1.
No, it's 10 dot. Oh, sorry.
10 no,
That was too
100.
bad.
It's 100. And here also I have
Okay.
configured the 100 only. Okay, you will learn later. No interface, VLAN 1 and no IP address. Now we can do one thing, interface F0/1 and no switch port. Actually this is multi-layer switch. No switch port. Command is not available here. Switch port mode trunk switch port trunk encapsulation. That command is also not available. I can do one thing then. Here I can add one PC for now. And on the PC I can configure that IP 10.10 10.1.1.10 255.255.255.0 and the default gateway 10.1. Not 10, sorry, 100.1.1 and here also it should be 100. Okay, and now from the router if I am going to ping this IP 100.10, it was 100.10 only, then ping should work now. Ping is working, and now if you will check ARP table,
Yes.
so IP ARP, you can see type is ARPA and the timer has started for this entry. There is no any timer age, no age. This is the permanent entry, but for this one a timer is started. Here we are not getting the exact output, but for all the dynamic entry it will start a timer. The by default ARP timeout is or time by default for how long a device is going to store the MAC address with IP address in their ARP table. Default ARP timer.
300.
No, 4 hours.
300 seconds.
4 hours.
Okay.
4 hours. Right? Means if you are not going to send any data to PC1 to 10 dot 100 for 4 hours, it will remove this entry from the table, and again if after 4 hours if you are going to send any data, it will regenerate the ARP request message. That is the behavior of any dynamic nature. For example, DHCP. If DHCP is going to give you the IP address, if your machine will assign IP address from the DHCP, there will be a timer that your device can use that IP address for a particular time, maybe for 24 hours. That depends on our configuration.
Release time.
Similarly,
After 4 hours.
for the MAC address table also, if switch is going to learn it dynamically, there will be a timer. After that time, it will remove that entry. Because guys, these are the devices, right? There are some limitation. It cannot store unlimited number of MAC address in their table, right? Depending on their memory, there can be a number, right? Any number, but definitely there will be a number. So if a device is not communicating, is not forwarding any traffic, then it will remove that entry. That is the behavior of any dynamic nature, dynamic protocols like your ARP.
Sir, after 4 hours, this MAC address is changed for this IP 1.10?
No, it will remove from the table. MAC address will be same. MAC address is the permanent address. But again, router don't know. Let's say after 4 hours, if router 1 need to send traffic again to 100.1.1.10, it have to generate the ARP request message.
Okay, sir.
Right?
MAC address is same, huh, sir?
Yes, MAC address will be always same, brother.
Okay.
MAC address is the physical
Okay,
address, permanent address of your device. Okay, so what we have seen that ARP table will be maintained by all networking devices where we can configure the IP address, how it will build the MAC address, and this was the dynamic. Statically also we can create the entry. Guys, if you what you want, let's suppose in your network there is a device like this. This is my switch. This is my switch, and the switch is connected with one server. Server, you know, server is a static device. Every day you are not going to connect the server to switch. You will reserve a port for your server that okay, on my E0/0 I will have this server always and always, right, whose MAC address is, let's say, anything A. But if I will talk about the employee's device, their laptop or computer, those can be the
It will change.
dynamic device, right? When you will come in office, you are going to connect to the switch. Maybe today you are connecting your device to port number 1, tomorrow port number 2, right? Like that. Similarly for wireless devices also, the ports are not fixed, not a static, but the server, it is going to be a static. And whenever this client is going to ping the server, what we know, that server is going to be always same. If my device will generate the broadcast message like the ARP request message, there will be flooding, right? If there are so many broadcast messages, guys, definitely it can reduce the performance of our network 110%. Why not? Because if 1000 devices are there, all 1000 devices are going to receive your ARP request message. They will check the destination MAC. Destination MAC is broadcast. Oh, it can be for me as well. It will check the type field. It will identify the actual payload is ARP request message. It will hand over to ARP protocol. When ARP protocol will check target IP address, then it will come to know that no, this is not for me. Let's discard it. So all 1000 PCs or servers are going to decapsulate the frame, unnecessary frame. That is what? Unnecessary CPU utilization only, isn't it?
Yes, sir.
Yes, sir.
So we will always try to reduce the broadcast message in our network to improve the performance, right? And if you want that this device should never generate ARP request message for this server, what you can do? You can make a static entry that hey, for this particular IP address 10.1.1.1, the MAC address is A. Never delete this entry. Similarly, I can tell to my switch that hey, always make this entry in your MAC address table that on E0/0 a device is connected whose MAC address is A. Otherwise, you know, switch perform unknown unicast flooding if switch is not able to find the exit interface, right?
Yes, sir.
So static and dynamically. Static is going to be permanent entry, dynamic is going to be for a specific interval of time. Now let's come to MAC address table. Yes, tell me guys about the MAC address table. Layer 2 device will maintain the MAC address table. How these devices are going to maintain the or build the MAC address table? Again, two methods are there. Static and yeah, go ahead. Yes, sir.
Okay, so I think you were speaking about the one input which is permanent with regards to the app, but you did not complete that train of thought.
No, brother, I am saying, see this. If this is the PC, if I am going to configure IP address manually here 10.1.1.1, this IP address is permanent or it will be changed after some time, or it will remove this IP address after some time. It will be permanent until unless you are not going to change it. This machine will be using this IP address. Why? Because this is a static method of allocating IP. Statically we have configured it. But if it will get this IP address from the DHCP server, there will be a timer that is called lease time. For that particular time only it will use that IP address. Similarly, if a device is going to make one entry in their ARP table that let's say 10.1.1.1 is my IP address and A is my MAC address. So this entry is permanent. It has not learned the dynamically through any protocol. Similarly, if I am going to make any entry in the ARP table, that will be permanent. But whatever MAC address it is going to learn dynamically with the help of ARP protocol, that will be dynamic in nature. Means after a specific interval of time, it will remove that entry. Same thing will happen in your MAC address table. Same thing is happening in ARP table.
So, sir, the main reason to do that is to increase the performance of our network, to avoid too much of broadcasting, isn't it?
That was the example, madam. That, see, if you want to avoid the broadcast message, you can create the static entry. That was example, right? A static entry will be permanent, dynamic entry will be for a specific interval of time, and the by default ARP timer is 4 hours.
Yep. Okay.
Now, MAC address table. You said MAC address table will be maintained by layer 2 device. How it will build the MAC address table? Again, two methods are there, static and
Dynamic.
Dynamic. If I am going to create any entry statically, it will be permanent. And if I am going to, if your device is going to learn the MAC address dynamically, then it will store that MAC address for just 300 seconds. MAC address table 300 seconds. ARP timer is 4 hours.
Okay.
MAC address table timer is 300 seconds. And next question, how switch is going to build the MAC address table? How it will learn the MAC address dynamically?
From the source MAC.
From the source MAC, very good. This is the first function of switch, learning source MAC address. And the second function is forwarding. How? Based on destination
MAC
IP
MAC address.
Right, the first function of switch is address learning. It switch always learns source MAC address, and on the basis of destination MAC address it forward traffic. Third function of switch is loop avoidance. Right, before talking about loop avoidance, yes.
Have you, like you said, like dynamic timing is 300 seconds. If any guest user like mobile or like in any employee like comes in the network, then it will remain connected for not more than 300 seconds. Or
for 300 seconds your switch will store that MAC address in table, means your switch will not perform a non-unique flooding. If it is keep sending the data, timer will be resetting, timer will be like becoming 0 again and again. If a device will not send any data for 300 seconds, then switch will flood that information.
Okay, got it.
Anything else? Any other question? Any other question? So these are the three functions first we need to learn in switching, and from here your switching is starting. Switching means forwarding data packet from one interface to another interface, or you can say frame from one interface to another interface. That is called switching. Switching comes from switch. Right? Switch is what? What is switch? When I am saying switch, guys, first of all let me make it clear. When I am saying switch, I am talking about layer 2 switch. When I need to call layer 3 switch or multi-layer switch, I will mention that layer 3 switch or multi-layer switch or distribution layer switch. But when I am saying switch only, that means I am talking about layer 2 device, layer 2 switch. Okay. So what is the function of switch?
Yes, sir.
Used to connect multiple networking devices together. Like my router is used to connect multiple network together. Switch is used to connect multiple networking devices together.
To extend the LAN network, we can say.
To extend the LAN network, you can say. Switch. Used to connect multiple networking devices together in the LAN. In the LAN. Can a layer 2 switch connect to different network, to different subnet? No.
No.
Because Because we know switch has single broadcast domain, correct? Switch has
Purport broadcast.
single broadcast. Router has purport broadcast domain. Switch don't has purport broadcast domain. Switch has purport collision domain. But
oh yes,
all the ports belongs to single broadcast domain. It cannot create two different subnet. Switch from LAN, local area network. Switch from LAN. In the MAC address table, guys, how many things will be there? One is MAC address, as you said, MAC address. Second thing,
IP.
not IP, sir, sorry.
Port number.
Port number,
Okay.
very good.
VLAN, sir.
Destination address.
Port number.
Destination MAC address.
Type,
VLAN.
how it has learned, static or dynamic. Then VLAN information. That's it. These are the components of
Okay, so MAC address you are talking
MAC
about.
address table. And what are the components of ARP table? IP, MAC,
IP,
and
MAC, type. Yeah.
Three components, right? So let's say I have two PC1 and PC2. If both has one NIC port, we can connect it together, no problem, right? But guys, if both the PC has single NIC and I have three PC, I can't connect it, right?
Yes.
I can't connect it. I have to add one more NIC on all the PC. All the PC should have two NIC for 3 device. For 4 device, if I need to connect 4 computer together, then all the devices should have 3 NIC, correct?
Yes. Yes, sir.
Then only we can connect. This is not the solution. This can be very costly, right? So here we need a centralized device to connect multiple devices together. And that centralized device is my switch. That centralized device is my switch. And I want you to explain the packet flow between two PC over switch in detail, step by step. In detail, step by step. We all know switch has memory, switch maintain MAC address table, right? I'm not going to configure any IP address on the switch. MAC address of this machine, PCA is 1 is A and MAC address of PC2 is B. Both are in same LAN because we know switch connects device in LAN 10.1.1.1 and here IP address is 10.1.1.2. I want you to explain the packet flow in detail with any packet, doesn't matter. It can be HTTP, Telnet, DNS, DSCP, ICMP, any message. Take example of any data. But tell me the packet flow in detail, step by step. How switch is going to learn the MAC address. This is E0/0 and this is E0/1. E0/1. If I will talk about the switch, guys, if someone is thinking about it, let me tell you. So my switch is categorized into two parts, manageable and unmanageable. Manageable, and right now I'm talking about which switch? Manageable switch. What is the difference between manageable and unmanageable?
Sir,
Unmanageable and plug and play, sir.
Yes, we cannot configure anything on unmanageable switch. And manageable switch are those switch which can be managed by us, where we can perform the configuration. According to our requirement, we can configure the switch. That is called manageable switch. So right now I am talking about manageable. Then again switch is categorized into multiple switches like layer 2 switch, layer 3 switch. You will be learning about these all things in future classes in more detail, but right now just assume that this is layer 2 manageable switch, and switch has memory. Memory means RAM, where it will make MAC address table. Where switch will store MAC address table? In their RAM memory.
Memory.
If power will goes down, if I will turn off the switch, all the MAC address will erase or not?
Yes.
It will. Yes.
If it is not stored in NVRAM, then
even we can note store the MAC address table, the dynamic entry in the NVRAM. There is timer, remember. Right, so this is manageable layer 2 switch. Two PCs are connected here, PC1 and PC2. PC1 is using MAC address A, PC2 is using MAC address B. PC1 is using IP 10.1, PC2 is using 10.2. On the switch you can see E0/0 PC1 is connected, on E0/1 PC2 is connected. Right now switch don't have any IP address. We'll talk about the switch configuration as well later, about the IP address as well, why we need one IP address at least on the layer 2 switch even. And see, when I am saying layer 2 switch, it doesn't mean that layer 2 switch cannot understand layer 3 traffic. No. It mean what? It mean it is going to forward the traffic based on layer 2 address. I'm very strict on this. When I'm saying layer 2 device, it doesn't mean it cannot understand layer 3. It can understand layer 1 to layer 7, but it will always forward the traffic based on layer 2 address. Similarly, router can understand layer 1 to layer 7, but it will forward traffic based on layer 3 address. So right now switch has empty MAC address table in their
memory,
in their RAM memory.
table, yeah.
In the RAM memory there is one empty MAC address table. Empty, there is nothing. There is nothing. For an example, here on the switch you can check the MAC address table. So MAC address table, command to check ARP table is show IP ARP. Getting again noise from somewhere. Karan, keep yourself on mute if you are not speaking. Command to check ARP table was show IP ARP, and this is the command to check MAC address table. There is one MAC address, and how it have learned this MAC address? Dynamically. I'm going to clear it. Clear MAC address table dynamic, and show MAC address table. Now is there anything? No. This is empty MAC address. Okay. And see the 4 components of your MAC address table. Are these same? Yes. VLAN information, MAC address, type, and the port number. You need to master these all 4 components. When I am saying switch has single broadcast domain, you know what it means? We can create multiple broadcast domain on the switch, but by default there is single broadcast domain. It doesn't mean then that on the switch we cannot have more than one broadcast domain. Even we can have per port broadcast domain. To divide the broadcast domain we have what? VLAN. Right? If someone is asking you what is VLAN, you can say VLAN is used to divide the broadcast domain on switch. By default all ports of switch belongs to single broadcast domain, and VLAN is a powerful tool. With the help of that I can make multiple broadcast domain on the switch. By default there is single broadcast domain on the switch, and with the help of VLAN I can create multiple broadcast domain. Why I am saying by default single broadcast domain are there? Because by default single VLANs are there on the switch. See, VLAN 1. VLAN 1, and all the ports are member of that VLAN, right? All the ports are member of that VLAN. So right now in my packet flow I don't want to include the VLAN even. You can ignore the VLAN because later we are going to learn the VLAN and then we'll see the packet flow over VLAN separately. Right now I am assuming that skip the VLAN. Just tell me about these 3 components: MAC address, type, and the port. How packet will flow over switch. Yes, who will explain? Start.
Sir, in telnet, sir, we are using telnet, okay?
Okay, let's say telnet. Here I am run the command.
Telnet work on layer 7 protocol.
Okay.
It generate the telnet request
My
then
PC
it's
will
sent to
generate the
this.
telnet. Tell me slowly. My
Okay,
PC
sir.
will generate the telnet request.
Telnet request, sir. Then it's sent to the transport layer.
Then it will send to transport layer. Okay.
Yes, sir. In transport layer, TCP protocol is working, sir.
Okay.
So TCP protocol
Telnet
first
uses
generate the
TCP
connection.
protocol at transport layer. Say like this.
Yes, sir. Yes,
Okay.
sir. See, so first it generate the connection between two PCs
It will put
before
this
sending the
message on
actual
hold.
data. Yes, sir.
Okay. And it will generate the SYN message.
SYN message, yes.
Okay.
Then there is source port, sir, destination port.
In the SYN
In
message,
telnet,
source port. Source port will be what? Random.
source port is random, sir. Random.
And destination?
And the destination port is 23.
Okay. Then?
Telnet. Okay, then it's sent to the lower layer.
Okay.
Lower layer. After
Network
that,
layer?
no, it's sent to the
Network layer will do what?
Network layer it sent the sir a sync. Then
network
source
layer
port,
will add the source IP and this is IP header.
source IP, destination IP, sir.
Source IP 10.1, destination IP 10.1.1.2. Then there will be some more
Yes, sir.
information, important information.
Then there is sir a port number is 6.
Protocol
then there is
number?
TTL, sir, 225, sir.
TTL 255. Very good. Then?
Time to live, sir. Yeah. So then after that, it's handed over to data link layer.
Okay. Data link layer will do what?
Then data link layer, sir, there is one source IP, destination IP. Then
source
there is port.
IP.
No, sir. First sync source port, destination port is same 1 to 102523.
Data
then
link layer will add what?
Source MAC destination. Source MAC destination.
A. Destination
Yes,
MAC will be
source
what?
MAC 8 unknown, sir. Unknown, sir.
It will check the ARP table.
Just 1 minute.
Then you check the ARP table of MAC address.
So be a broadcast.
Source MAC and destination MAC. But destination MAC will be the blank or maybe question mark. I think.
Okay, for the destination MAC, your PC will look up ARP table.
ARP table, sir.
If
in ARP table, if the MAC address is there, sir, it encapsulates the data.
Great. And if
otherwise,
it, is not there,
it holds the traffic, sir.
And then?
Otherwise, it holds the table.
If I am sending the data for the first time, then definitely it will hold the data because it is
hold the data, sir, yeah.
not available. So what will be the next step
sir.
now?
It will generate ARP request, sir.
ARP request.
Yeah.
ARP
request, sir. ARP request.
Okay.
Then
In the ARP request, there will be target IP address.
Target IP, sir. Then target MAC is unknown.
Okay. Target MAC will be unknown.
Then
very good.
Yes, sir.
Then at layer 2 again.
After that, sir.
Source MAC A, destination MAC.
Destination MAC, sir.
All F, broadcast, ARP request message.
Yes, off, sir, yeah.
And then it
yes,
will
sir.
hand over to lower layer, physical layer will forward it from the...
Yes, sir.
In the bits and in the signal form.
From the link, yes. And then it will send from the link. You know, your switch is only going to check layer 2 header. Your switch will not check ARP request message here, okay? It will only check what? Layer 2 header, Ethernet header to forward the traffic. And if interviewer is asking you this question that when I will send telnet packet from PC1 to PC2 for the first time, through which message switch is going to learn source MAC address A? Message is in front of you.
ARP request.
Right? Now, I'm modifying the question. When I will send any data from PC1 to PC2 for the first time, through which message my switch is going to learn the source MAC address?
Dynamic MAC address?
Yes, how it will learn the MAC address? With the help of which message? ARP request message, right? Whether you are sending telnet traffic or ICMP traffic or SYN message or HTTP traffic, every time if MAC address is not available, and if you are sending the message for the first time, MAC address will be not available, right?
Yes, sir.
So it will generate the ARP request message, and through ARP request message my switch is going to learn what? Source MAC address, right? One switch will receive this frame, it will check this frame is coming from where? Frame is coming from a MAC address, right? That means on my E0/0 a device is connected whose MAC address is A. It will make this entry in their MAC address table that hey, my E0/0 or MAC address is A of a device which is connected on E0/0. And how I have learned it? Dynamically. Right?
Sir,
And
there is two message to hold. One is sync, the other one is ARP request. If the destination MAC
ARP
address
request is
not
not
there.
on hold, brother. ARP request
yeah,
has
okay,
gone.
sorry.
It reached to switch.
Sorry.
Telnet and sync.
Yeah.
MAC
Right?
address is there, yeah.
It has learned. And now the another function of switch, forwarding. It will check now destination MAC. Destination MAC is broadcast. So always keep in mind, before checking destination MAC, switch will check source MAC.
Source MAC address.
And it will update their MAC address table, and the timer will start from the 300 second, right? 300. After 1 second, it will become 299 second, then 298 second, then 297 second, and as this timer will become 0, it will remove this entry. Okay, as it will become 0, it will remove the entry from the table. So if PC1 is not going to send any data for 300 seconds, again it will not have any entry. This time it has entry and it will forward the traffic to PC2. Very good. PC2 will generate ARP reply message. It will generate ARP reply. Similarly, that will be unicast and it will send to switch. And when it will ARP reply message will reach to switch, again switch is going to learn what? B MAC address.
MAC address.
On which port? E0/1. How? Dynamically. Again, dynamically. Now ARP request and reply has exchanged. Now both the PCs has MAC address of each other. Both the PCs has MAC address of each other. So which message was on hold on PC1? SYN message. Before telnet SYN message, right? So now it is going to encapsulate the SYN. In the SYN message, destination MAC will be
B.
Destination MAC will be B. And there will be one more important field. What will be that? What is that?
Type.
Type. What will be the type code?
0806.
No, that is the type code of
800.
No, this time it will
800,
be
sorry.
800.
800. Right? And now again my PC will send it to lower layer physical layer. Physical layer will convert into bits and then it will send to my switch.
Destination.
My switch. It will send to my switch. And again, switch is going to check what? Source MAC first. What is the source MAC address? A. Let's say when switch is receiving this second SYN message, the second message, the timer for this entry is 290 second. 290 second. So what switch will do? It will update this entry. This timer will again become what? 300 second. Whenever switch will receive the frame from PC1 on 0/0, it will update their table. And when I am saying update their table means it will reset the time. It will reset the timer. Okay, guys?
Yes, sir.
Sure.
And after that, switch is going to check destination MAC address. Destination MAC address is B.
B.
To forward the traffic to B, again my switch will look up here MAC address table, and for B MAC address, exit interface is 0/1. It will forward from here. And now PC2 is going to receive it, right? This is how switch will perform. unicasting, unicast communication. Now I am assuming that okay, switch has received it, but if this entry is not there in the MAC address table of switch, then what will happen? Switch has received the frame, it has
Broadcast.
updated the table. Now it has checked the destination MAC. Destination MAC is B. For the destination MAC B, there is no any entry in the ARP table. I'm sorry, MAC address table. What switch will do?
Broadcast.
Which will
Not
broadcast to
broadcast.
the old ports, except
Not
each
broadcast.
new entry.
Broadcast means the destination MAC address is broadcast. Here destination MAC is not broadcast. That is going to be, guys, forwarding the traffic from their all interface except receiving interface. But that message is not broadcast. It looks like broadcast, but it is not broadcast. That is
Unknown unicast flooding.
Unknown unicast.
very good. Unknown
Unicast.
unicast. Unicast flooding. There is some difference between broadcast and unknown unicast flooding. Both definition of both is forwarding traffic from their all interface except the receiving interface. But in the broadcast, destination MAC will be all off, like your ARP request message. In the unknown unicast flooding, destination is unicast. The packet, the frame is my unicast message, but switch don't have port number for that particular MAC address in their MAC address table, right? That's why switch is doing broadcast unknown unicast flooding, forwarding it
So
from their
in
all
that,
interface.
so in that frame, it would be B as a MAC address.
What be?
In
Yeah,
the frame.
but frame
In the
is going to
frame.
be same.
Okay.
Frame is going to be
But
same. Switch is not going to modify anything, right? But there is
but
one
the
another
table doesn't
PC.
have B.
Yes. Another PC C. C, whose IP address is 10.1.1.3. So this message, see, the actual message is for PCB only, right? For PC2, not for PC3. But as switch don't have information about the destination port number, destination MAC address, it will forward this to PCB as well as PC C. When PC C will receive, it will check destination MAC. Destination MAC is B. Their MAC address is C. It is not for PC C. It will discard it at layer 2. Right? When PC B will receive it, it will check destination MAC is B. Yes, this is my MAC address. Means someone has sent the message to me. Let me check the type field. What is the type field? 0x0800 means upper layer protocol is IPv4. It will remove this header and it will hand over the packet to network layer. Network layer will check destination IP. Destination IP is 10.2. Yes, this is my IP address. Let me check the protocol value. Protocol value is 6. Let me hand over rest traffic to TCP protocol. TCP protocol will check destination port number. Destination port is 23. Let me remove this header and let me hand over the request message to telnet protocol. It is like that. In that case, in this case, this is SYN message. So PC will generate the SYN plus ACK message, right? But guys, here in the MAC address table of switch, MAC address will be available because just before few seconds, both the machine has exchanged the ARP request and reply message, correct? So they have the entry. So switch will not perform unknown unicast flooding. Switch will perform unicasting. It will receive on 0/0 and it will forward from 0/1. 0/1. Right? This is my packet flow, and now the actual telnet request message will be sent, right? After the SYN message, your PC2 will send SYN plus ACK, then PC1 will send ACK message, right? Then TCP connection will established here between these two PC, and after that, over that TCP connection, it will send actual telnet message. So on the switch, what we need to learn, Praful? On the switch, you need to learn how to manipulate this MAC address table. What it mean? It mean, let me give you the another example now. It mean every switch has the limitation. It can store limited number of MAC address in their table, right? If you want to see that, let me show you. Let me open my EVNG, because all the commands are not available in packet tracer. For now, even you don't need to verify these all things. While teaching, I will show you, right? You can skip it, just learn it. It is important. You don't need to set up EVNG just to check how many total MAC address which can learn. Later you can check it. For now, packet tracer is sufficient for you. I am going to use my EVNG because I want to show you some advanced commands. In the EVNG, you can run all the commands which are available on real devices, on real physical switch. Actually, in the EVNG, we are importing the real image of router, switches, firewall. So that's why I'm going to open the EVNG, but for you, packet tracer is good for now.
We can use multiple vendor devices in EVNG as well.
Yes.
Okay.
192.168.241.138. Try to understand, this is very important, and this is the first thing which you need to master in the switching on the switch. Admin, if let me see if I have any lab related to that. Switch, spanning tree, troubleshooting, switching. Switch basic. Okay, let's say this one. Here it is, the another one. Which one it is? Let me use this one, the switch basic. Forget about the other things like these all. I'm going to delete it. Okay, if I will access my switch number 1, forget about the trunk and VLAN. Just I want to show you one thing here. So MAC address table count. See, this switch can learn this amount of MAC address. This is the total number of MAC address that switch can store in their MAC address table. Now you can say,
So it is
Praphul,
different for different models of switches?
Yes. It depends on your operating system or the hardware.
Okay.
Now you can say, Praphul, really this is more than sufficient. Why? Because generally on the switch I have seen 48 ports, 24 ports, 16 port, 8 port. So why switch need to learn these amount of MAC addresses? Guys, just understand here, if I have a network, in my network there are 100 number of switches. 100 number of switches connected like this. How will connect the switch? That also you will learn. For now, let's suppose these are connected like this. Switch 1, 2, 3, 4, 5. Later, you are going to learn one topic called stacking. Is there anyone who knows stacking? What is stacking? Stacking is a technology to
Combining
multiple physical switch into single logical switch. Let's say I have two switch. Both switch has 48 ports. How many ports? 48 ports. So total number of ports are 48 plus 48.
96.
96, right?
96.
If I need to connect these switches, I will use cable here. I will use cable over here, right? Let's say on this PC, we have 48 ports, and these all ports are fast Ethernet port. What is the bandwidth of fast Ethernet port? 100 Mbps.
100 MB.
100 Mbps. 100 Mbps. So how many links I have between switch 1 and switch 2? 100 Mbps. Here I have, for an example, one PC. Like this, I have 40 PC here. 40 PC. This PC is connected to this switch. This PC is getting how many bandwidth? This PC is getting how many bandwidth, guys? 100 Mbps?
100.
100 Mbps. Here also on switch number 2, exactly we have 40 PC, and this all PC will get 100 Mbps link, right?
100 MB.
But can
Yes.
these all 140 PC on switch 1 and switch 2 exchange data at 100 Mbps per second at this rate? No. Why? Because the link between switch 1 and switch 2, we have a single link here. And the bandwidth of this link is 100 Mbps. So that bandwidth is shared. That is shared bandwidth, right? All 40 users on switch number 1 and all 48 users on switch number 2 are using the same 100 Mbps bandwidth between switch 1 and switch 2. Am I right?
Yes.
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 So we need to increase the bandwidth over here between switch 1 and switch 2. So I will ask you to connect 8 cable here. How many cable? 8 cable. Now what is the total bandwidth between switch 1 and switch 2?
800, sir.
No,
800.
2, 4, 6, 7, 8. Now we have 8 Mbps. Again 8 Mbps is shared. A PC, all the PCs has 100 Mbps of link, but they can never send data at this speed, this rate. Right? Because 100 Mbps link is not there between switch 1 and switch 2. But if you are going to use more link over here, then guys, you will get very less number of port on switch to connect the user. What is the function of switch? To connect multiple LAN devices. Function of switch is not to connect two switch together. So we will never use, most of the time, sometime definitely we will use this technique as well, right? We'll use the fast Ethernet link to connect the ports, and on switches you will find few gig link as well, hardly 2, sometime 4, depending on platform of devices. But and if you are going to connect 2 link between the switches, it will block one switch by default. So later you will learn a technology to use all the links, that is called ether channel. You will bind all the physical link logically, right? Those are the topics of our upcoming classes. But for now, just I want to make you understand one thing, that if I will add so many link here to increase the shared bandwidth between switch 1 and switch 2, the number of ports for user will get reduced, right?
Yeah.
So that's why we come up with a stacking technology. Stacking allow you to combine your 2 physical switch into a single logical switch. 2 physical switch into single logical switch, and you will not utilize the fast Ethernet port which are for the user. You will create one logical switch here, and how many ports will be there? 96. 96 ports. On the single switch, it is going to behave like a single switch. Praphul, 96 port. We are not going to use any port to connect switch 1 and switch 2. No, you are going to use another type of cable that is called a stack-wise cable. On the switch, you will find one more port, similar like your fast Ethernet port, that is a stack-wise port, and you will connect these 2 switches through a stack cable. So on the single switch, we have 96 ports. Similarly here, if I am saying in this scenario, you can assume that these switches, switch 1, switch 2, switch 3, switch 4, are the stack-wise switch, are in a stack. And how many ports are there? Multiple ports. On one switch, let's say 500 ports are there. Here, how many ports are there? 500 ports. On all the switches, 500 ports are there on switch number 5, 500 on 4, 500 on switch 3, and 500 on switch number 2. 500 users are there on these all switches. So switch 1 is going to learn all these 500, 500, 500, 500, 2000 MAC address on this single port. Yes or no?
Yes.
If I need to forward traffic to these all 2000 devices, I will forward traffic from this port only, right? It is going to learn all these MAC addresses on single port. So in the production, on one port you will find many MAC addresses. Switch can learn more than one MAC address on single port, but switch cannot learn same MAC address on multiple port. That is loop. That is another thing. So even this MAC address, this amount of MAC address is not enough. Switch can have more than this amount of MAC address. Now try to understand one more thing here. Let me give you one more example here, and after that I will directly come to my topic, the MAC address. Let's suppose this is my switch 1. Here we have multiple types of users, server. Some servers are there, different kinds of devices are there, 2500 devices are there, and these devices are PC, server, printer, right, IoT devices, different kind of devices are there. And servers are a static device. Some are a static device, some are, for an example, I am saying business critical devices, people often send traffic for that server. For example, this server, this switch is connected with one router. Any switch number 5 is connected with one router, and router is connected with internet. And the user from the internet, later you will learn how user can access my internal server, but I am assuming internet user. Guys, when I am saying internet user, means I am talking about million of user, right?
Yes.
So if the internet users are accessing this server, that means we are getting huge number of traffic on this particular server every day, night, 24/7. If any switch don't have the MAC address of this server in their table, they will perform flooding, a non-unicast flooding. If device don't have the MAC address, they will generate the ARP request. So don't you think that switch should store the MAC address of this server in their MAC address table for long time? And at the same time, there are some general users who often send traffic, who hardly send traffic, maybe once in a day. So switch should store that MAC address for long in their MAC address table?
No.
No. That means MAC aging time, which is 300 by default, should be not same for everyone in the network, right? For some department, for some devices, it should be minimum. And even if switch MAC address table is full, means switch is using their all CPU, then it will provide low performance, right? It will return you low performance, right? If the space is free, more space is available, it will perform better, right? Behave well, right? The performance will be high. As a network engineer, you have to take care about these all things. If there are so many non-unicast flooding in your network, what will happen? Performance will get reduced. If everything is, guys, in systematic way, yeah, you have reduced, you have checked your network various time, you have optimized the performance, and based on your company business need, you have configured the network, then only it will behave well, it perform better, right? Yes. So the general users MAC address should be stored for few times, who hardly send traffic, right? If let's say PC1, this PC had sent the first message to this server or to the internet, for the internet has generated www.google.com after 10 days, and this is the last message. After next 10 days again it is not going to generate any message. So why these all switches in my network will store their MAC address for 300 seconds? It should not store. You know this, that everyone from the sales department hardly generate traffic, right? You know this, that my switch should not store the MAC address of sales department in their table for long, but at the same time we have some critical traffic and we don't want a non-unique passwording for that. Then switch should store that MAC address for long. Maybe some MAC address will be static in the MAC address table. Statically means it is going to be permanent, means which will never perform a non-unique passwording for that particular MAC address, right? Like if someone from the internet is going to forward the traffic for this internal server whose IP address is 10.1.1.1, the traffic will reach to my router, which is my gateway R1, and then gateway will forward it to switch. Gateway will forward it to switch. Switch will check what is the destination MAC. First it will learn the MAC address, update their MAC address table, the default gateway MAC address, and then it will check destination MAC. Destination MAC is A. It will compare this MAC address with the MAC address table. If the entry is not there, it will perform what? It will perform what? A non-unique passwording.
Non-unique flooding.
It will, switch 4 will also perform, switch 3 will also perform, switch 2 will also perform, switch 1 will also perform. Don't you think that performance will get reduced for particular time? Yes, 100%. And if you are going to create the static entry, or let's say the timer for a MAC address is 1 day, 24 hours, then in a day hardly once your switch can perform non-unique passwording, right, for this particular server. And we know this is critical. We are receiving so many traffic. So MAC aging time will be not same for all the users. And what is the default timing? You can check that. So MAC address table aging time. See the aging time. The global aging time is 300
seconds.
300 seconds.
So
this is global.
all the switches in the stack will have same MAC address table. I mean, only
Yes,
one
that
MAC
is
address table
single
will be there?
switch only.
Okay.
In the stack, if you have combined the multiple switches, that is going to behave like a single switch. Just
Single switch.
assume that
Okay.
that is single switch. For an example, here I have two switch with 4 ports. 4 ports plus 4 ports. Port number 0/1, 0/2. Let's say 2 ports, 0/1 and 0/2. This switch also has 0/1 and 0/2. So when you will combine it in the stack, you will have single switch, and on the single switch you will have 4 ports, 0/0/1, 0/0/ what? 2, 0/1/ sorry.
0. What is this third slash for?
1/0/1, 1/0/2. These are the 4 ports. The first one is stack wise number of switch 1. Second is their slot number, then port number. So you can assume like there is single switch and these are the 4 different ports. First number is stack wise number that will be added in the stack. But if you need to configure this in VLAN 10, you will say interface F0/0/1 switch port access VLAN 10. If you want to put this port in VLAN 10 on switch number 1, you are going to run command interface F0/1 switch port access VLAN 10. It is like that, and we'll see it in stacking. Don't worry. MAC aging time. Now, right now, this switch don't have any MAC address in their MAC address table, right? For an example, if I'm going to configure IP address on this PC1 IP and 10.1.1.1/24, will it generate any message? Is there an entry? No. I'm going to send any traffic to any IP address 10.1.1.5, any, IP, and now if you will check MAC address table of your switch, there is no any entry. Why? So interface status 0/0 port is connected. So VLAN brief, all the ports are in VLAN 1 only, that is correct. Why it is not learning the MAC address of PC1 when I am sending traffic? The switch should learn the MAC address. Switch 1. IP 10.1.2/24. Checking duplicacy. How it will check the duplicacy? With the help of grp. I think on the PC1 IP was
Great.
not configured. It was already configured. 10.1 and switch is not learning the MAC address. This is the error of simulation. Let me send the traffic now from PC1 10.1.1.2. Ping is working. MAC address table. Okay, I am checking the MAC aging time, guys. I am so sorry. So MAC address table. This is the command, na? I am going to clear it. Clear MAC address table dynamic, and so MAC address table. Now there is nothing. There is nothing. Again, if I will say IP 10.1.1.5/24, it will generate grp, and once it will send the grp to switch, switch should learn the MAC address. You can see on 0/0 interface it has learned the MAC address. First thing, this is the MAC address. Second thing, type and the port number, and the MAC aging time is 300 seconds. How many MAC addresses are there in the MAC address table?
2 right now.
Total MAC address, and both are
Dynamic
in nature. So timer is running after 300 seconds. If you will check the MAC address table, you will see these entries will be erased, flushed. This MAC address will be flushed by my switch and MAC aging time. So MAC address table aging time 300 seconds. Now, as I told you, for different departments your MAC aging time is going to be different, right? So guys, you will manage your MAC aging time with the help of VLAN. Like for VLAN 10, MAC aging time will be different, right? And in VLAN 10, let's say I have the servers, critical servers, so I can say MAC address table aging time, and let's say 500 seconds for which VLAN? For VLAN 10. Now you can check the MAC aging time again. Now what it's saying, the global aging time is 300 seconds for all the VLAN, but for VLAN 10 MAC aging time is 500 seconds. Now switch will store the MAC address of any device in VLAN 10 for 500 seconds. Right? If I am going to create any static entry, MAC address table and then address. Let me put question mark. Static. Type is static and then address. Address or something. The MAC address. What is the MAC address of PC1? Let me check. So IP all. Here is the MAC address of PC1. Or from here you can check. This is the MAC address. Both are same, right? I'm saying this is the address, and bind this address in VLAN 1 on which interface? On interface Ethernet 0/0. This is how we can configure, create the static entry. Now if you will check MAC address table again, so MAC address table, you will see there are two types of MAC address, static and dynamic. Total MAC addresses are 3. The first important thing, you should check your MAC address table like this. So MAC address not like this. If you will run this command, you will find lots of MAC address. It will be difficult for you to find your MAC address. First filter it with the help of a static or dynamic. Show me the static MAC address. Here is the static. And then show me the dynamic MAC address. It will show you all the dynamic MAC address. While troubleshooting, you need to find that, see, in the production, guys, your switch will be in the rack, correct? My switch will be in the rack, and on the desktop, on the table, these PCs are there, right? Connected like this. True? Let's say this user is a sell person, and he is complaining that he is not able to access the website. He is not able to access the website, and somehow you observe that there is some issue on the switch, and you want to verify the switch is learning this MAC address or not, right? So you know the MAC address of PC, or you will ask to the salesperson that, hey, can you share your MAC address, or you can ask, can you give me the remote access of your laptop, I need to check your MAC address. And also you will have the MAC address of the client machine, which is this one. You can check the table. I can say show MAC address table, static, and then address. Show me this address. Have you any entry for this address? And let's say you want to identify this PC is connected on which port. This PC is connected on which port. So it will give you that information that this port PC is connected on E0/1 port. These are the troubleshooting techniques. MAC address table is so simple. Learning how switches building the MAC address table is simple with the help of source MAC address. But the most important thing for you is how to use this MAC address table to fix the issues in the network. If there is any issue, this is very useful table. And switch forward traffic based on MAC address table only. So if there is any issue on the switch, you have to understand the MAC address table first very carefully. 1 minute. Not only this, if someone is asking you, hey, can you tell me what is the MAC address of a device which is connected on interface E0/1? You can say yes. And how you will check that? So MAC address table, interface E0/0. It will show you the MAC address on this particular interface. Right? By the way, even switch is not going to run this command, show MAC address table, to forward the traffic. Switch is going to run this command, show MAC address table VLAN 1, like this, filtering, right? Switch never check entire MAC address table to forward the traffic. It check MAC address of a particular VLAN, because switch can forward traffic in same VLAN. You know, switch form LAN. Switch cannot forward traffic between the VLAN. So if I am saying these two ports are in VLAN 10, let's say, maybe you don't know the VLAN, no worry. Interface range E0/0 to 1, and switch port access VLAN 10. And so MAC address table. Now you can see in the VLAN 10, we don't have any MAC address. Now if PC1 is going to generate traffic, ping 10.2, ping is not working. Why ping is not working? Can anyone tell me? And can you troubleshoot it? Why ping is not working? Can you troubleshoot it? See the IP address on PC1, 10.1.1.5.
Because it belongs to different VLAN.
No, both belongs to same VLAN. Both PC belongs to same VLAN. So IP all 10.2, and on the PC,
Sir,
on the switch.
So there is not assigned the MAC default gateway.
Default gateway is not required. Both belongs to same network. Why default gateway is required here? Not required, na? Not required.
Ports
And
are
you
not
can
one.
see
Sir,
0/0 and 0/1
two
are
ports are
in.
in VLAN 1 and two ports are in VLAN 10.
No, see, these two ports are in which
So
VLAN? In VLAN 10 only, right? PC1,
10.
PC2. So they should communicate, na?
Hmm. Okay, you are
Both are in
pinging both
same
of them.
broadcast
Okay.
domain. If both are in same broadcast domain, they should communicate. But when I am pinging, you can see ping is not working. Now see ping is working or not. Now ping is working. For 30-second ping was not working. Keep in mind, for 30-second ping was not working. Why? You will learn it. Now if you will check MAC address table of VLAN 10 again, now you can see there are two entry. The MAC address of PC1 is here. This is the MAC address of PC1. And if I am going to run command show MAC address table static, you can see there is one static entry as well. This is and this is. Both the MAC address are same, right? Both the MAC addresses are same. Same MAC address is in VLAN 1 as well as in VLAN 10. Why it is in
10.
VLAN 1? Because this is a static, right? This is permanent entry.
Okay. Yes.
Until unless you will not delete it. Who has configured the wrong entry here? You. Statically. So switch is not going to remove her. It will be permanent. If I am going to ping, let's
Sir,
say
if
this.
if we bind like this only, like there is a server and we bind the MAC address like static over here,
Okay.
and then we remove the server and put a different PC over there,
Okay.
having different MAC address, then what will happen?
It will learn that
Because
MAC
we
address
have bind the MAC
dynamically.
address.
I told you, switch can learn
But
multiple MAC address on same port. It will be
but we
having
have
two MAC
configured
address.
static.
So one will be static,
But
one
by
will be
mistake we have,
dynamic.
like this one.
What you are saying that here the PC, there was one server and the server MAC address was A, and here I have bind that MAC address A on
Like this example.
A0/0. And now later I have changed the device here. Now new MAC address of device is B. So when this machine will send the message, it will also learn B MAC address on E0/0. One is static and one is dynamic. Both MAC address will be there on the same port.
Maybe he's confused with port security, I think.
No, this is good question. But switch can have multiple MAC address. Even statically we can add multiple MAC address. Let's say here on the switch, for an example, what is happening?
So it will work?
Yeah, it will work. 100% it will work. Guys, here I have one switch. Right? I have one small company, very small company. And there are some ports. Let's say 4 ports and 4 employees are there in my company. I know these employees will connect their laptop every day to my switch every day. But this is not sure that which client machine is going to connect their PC on which port. And I don't want a non-unique passwording. What I can do? I can bind all these MAC address A, B, C, D on all these 4 ports. On all these 4 ports. Right? This port will also have ABC MAC address D. This port will also have ABCD. This port, all the port will have ABC statically. Right? So if PC B will connect their device on port number 1 or PC1 or PC3, all will work. No problem.
Okay.
On the switch, or even I can say MAC address table static, and the address, let me copy this address, and I'm saying 7 on which port? On interface, sorry, in VLAN 10 or 1, in any VLAN, VLAN 1, and interface is 0/0. Now you can see you have bind how many MAC address? 2 MAC address on
What?
0/0,
Okay.
right? So either
Okay,
this
so we can bind. Hmm.
yes,
And if we connect different device, it will dynamically learn that as
yeah,
well.
correct.
Okay. Okay, now I
When it
got
is
it.
running dynamically, there will be timer, and we can
Timer.
increase or decrease that timer, right? Packaging time,
Yes, yes.
we can increase or decrease
Perfect.
that timer. So this is how you can manipulate the MAC address table of switch. See, so MAC address and put the question mark. See how many commands are there. We can filter it with the help of VLAN. We can filter it with the help of static. Forget about the secure and multicast. We can check on the particular interface. We can check the dynamic entry. We can check the MAC address count, that switch can learn how many MAC address. We can check the aging time, and we can find the port with the help of address. Either we can find the address with the help of interface, or we can find the interface with the help of address. If you know the MAC address, you can find the interface. If you know the interface, you can find the MAC address. With the help of MAC address, we can also find the PC belongs to which VLAN. For an example, I want to check that this PC, this is the MAC address of one device, and I want to check that this device belongs to which VLAN. So again, so MAC address table, and then address and this one, and it will give me the information that okay, in VLAN 1, in VLAN 10 and VLAN 1, right? This PC can be in VLAN 1 as well as in VLAN 10. While configuration, MAC address table and then put question mark. You can configure the aging time, and you can configure the static entry. When you will say static, it will ask you what is the address, then it will ask you the VLAN ID, then it will ask you the interface. All 4 components, all base. And we can check our MAC address table with those all 4 components: VLAN, interface, address, and type. I can say MAC address table, static, dynamic, MAC address table on this interface, MAC address table for this address, MAC address table in this VLAN. Yes or no? This is why I first said that there are 4 components of MAC address table, so that you can understand we can manipulate it with the help of these all 4 components. Today we have talked very basic thing about switch, guys, which is the MAC address table, but this is so important because whatever features of switch or protocols you are going to learn, like your STP, your VTP, your DTP, your VLAN, trunking, .1q, ISL, ether channel, port security, all are based on your MAC address. And hope it is clear. Now if anyone have any question from the MAC address table of switch, please ask. We know that switch build MAC address table dynamically by learning the source MAC address. Whenever it will receive the frame on interface, it will check what is the source address, and it will make the entry in their table. Hey, I am receiving this frame on 0/0 and the source MAC address is A. That means a device is connected on this particular port whose MAC address is nothing but the A. And this interface is a part of VLAN 10. So let's make an entry in my MAC address table. In VLAN 10, a device is there whose MAC address is A, which is connected on port number 0/0, and I have learned it dynamically. Clear?
Yes, Professor, I have one question.
Yeah, go ahead, sir.
So, if a device with MAC address A is connected to port number 1, okay, and we have entered the static entry in the MAC address for device A and port number 1, and after that we will remove that device from port number 1 and connect it to port number 10. Then the switch will send traffic to both the ports
You
for
can
same
create
MAC
the issue.
address.
Try to understand this scenario, guys. Let's say
Yeah.
here what I have configured. Let's say I have 2 switch. Switch 1, switch 1 and switch 2. Here I have one PC whose MAC address is A. And here is a PC whose MAC address is B, right? This is 0/0 interface. This is 0/0 interface. This is 0/1 interface. And this is also 0/1 interface. Let's say I have created the static entry here in the MAC address table of each one. That is, a MAC address is 0/on 0/0 interface. Bind it on 0/0 interface statically. And on switch number 2 also I have bind a MAC address on 0/1 interface statically. What will happen now? What will happen now? Tell me. The IP address is 10.1.1. IP address is 10.1.2. What will happen when 10.1 will ping to 10.1, 10.2? Source MAC A, destination MAC B. PC will forward this traffic to switch 1. Switch 1 has already the static entry for a MAC address. There is no any issue. It will forward traffic to switch 2. Switch 2 will learn a MAC address on this port dynamically.
Yeah.
A MAC address on which port?
0/1. 0/1.
0/1. Where is the message? Here it is. 0/1. It will check destination. It will forward to PC2. PCB will generate reply. Destination MAC B. Sorry, source MAC B and destination MAC
A.
It will forward to switch 2. Switch 2 will learn B MAC address on which port?
0/0.
B MAC address.
Yep.
And then it will check destination MAC A. It will forward the traffic to
0/1.
0/1. Switch 1. Switch 1 will forward it to, again switch 2. 1 will learn B MAC address on 0/1 and it will forward to
0/0.
0/0 means to
0.
PC1. Is there any issue? No, they can communicate, and you should always check packet flow like this only. You should always check packet flow like this. Now, if I am saying there is B MAC address, learn B MAC address on which port? 0/1 port statically. Static. Now what will happen? Now what will happen? Again, user will generate traffic, source MAC A, destination MAC B. It will forward to switch. Switch will update their entry and it will check the MAC address table. It will check B MAC address is on which port. It will find 0/1. It will forward to switch number 2. Switch 2 will learn A MAC address on 0/1 port. It is already there statically. It will check destination MAC B for the destination. See the static entry. On which port? 0/1. It will reverse the packet to switch number 1 back. Again switch 1 will forward to switch 2. Again switch 2 will forward to switch 1. Right? Because what about this entry? This is dynamic in nature. After some time it will remove. After 300 seconds, right? So it can cause the issue in your network. So many things are there over switch. We'll discuss those all things in future classes, and day by day these all dots will be becoming clear.
So what is the best practice? Sorry. So what is the best practice by configuring the MAC address table?
Best
Or
practice is,
like,
we in the production we configure a static entry for the static device. Now what is a static device? A static device means the devices which are fixed, permanent, like a
fixed.
printer. You are not going to connect your printer to switch every day.
Yes, true.
Server, right? So we know that every day, every time my printer will be connected on this device, so my switch should not perform a non-unicast flooding ever. Better to configure the static entry for that, right? Sometime, for an example, if I will talk about my home setup, in my home there is one server. On the server, SD-WAN lab is there. SD-WAN lab is there. So whoever are enrolling for SD-WAN course are getting access of this lab. How? Through internet. Actually, in my home there are some PCs, 4 PCs are there, one server, right? One printer is even there, and these all devices are connected to switch. These all devices are connected to, this is the network of my home. Right now my laptop is connected with this network only, and then this switch is connected with one firewall. I am skipping that just to secure my internal devices. I have deploy one firewall. Then the broadband router is there, directly I am adding it, and after that the broadband router is connected with internet. This is my home network. And my SD-WAN students has also internet access, internet connectivity. So they have the public IP address of my SD-WAN lab. They will simply open their browser and type the IP address. They will get access of my server. How? Reply will reach to the request from the user will reach to the router. Router will forward it to switch. And every time switch need to forward traffic to the SD-WAN lab only. The MAC address of this SD-WAN lab. Actually, even this is not the physical running on physical server. This is my VM. SD-WAN lab is virtual machine. Right now here even you can see my EVNG is running on VMware, is one virtual machine. The IP MAC address is A. Every time switch need to forward the user traffic, outside traffic to the server. But if switch will not find the MAC address in their MAC address table, then it will perform a non-unicast flooding. To reduce it, what I can do, I can make a static entry over here. After making a static entry, my switch will never perform a non-unicast flooding for SD-WAN lab, right? Yes. So whether it is a small network or large enterprise, every time you will configure some MAC address statically on the table, and you will manipulate the MAC aging time. And while troubleshooting, you should have knowledge about MAC address table, like how to find the interface from the address, how to find address from the interface, how to find the VLAN ID with the help of MAC address, right? Because user is only going to tell you that I am not able to access the network or service or server. It's your responsibility to ask the IP address, hey, tell me your IP address, hey, tell me your MAC address, and on the basis of that two information you have to troubleshoot the issue. Getting my point?
Yes, sir.
You should be able to access the MAC address table from all the angles, from all these 4 components, and you should be familiar with these all 4 components. If you are familiar, good. Congratulations, you are good in the MAC address table of switch. Apart from this, there are so many things. Just keep everything aside for few classes. Day by day we will be learning protocols here, right? Your dot will be cleared in the future. If anyone have question in or have difficulties to understand the MAC address table, like how switch build MAC address table, how switch is going to use that MAC address table, what are the components of MAC address table, and how to check the MAC address table. Anyone?
Yeah, sir. Yeah, sir, about the aging time, the 300 seconds only apply if there's no traffic flowing, right? if there's still traffic flowing, then the 300 seconds doesn't change. I mean, the dynamic MAC address will not change, right?
No, timer will be resetting only, right? Let's say the switch has received one first frame on this port, on 0/0 port. What it will do, it will make entry that hey, on my 0/0 or device is connected whose MAC address is A, and timer will start 300 second, 299 second, 298 second, 297 second, and after 290 second again it is receiving one frame, so it will reset the timer, again it will become 300 second.
Yeah.
If the user will not send any traffic for 300 second, then it will remove the entry.
Okay. Yeah. Okay. Thank you.
Yeah, welcome.
And then it will perform you unknown unicast.
Yes, then it will perform unknown. If switch is not able to find the port number for destination MAC address, every time it will perform unknown unicast flooding. Unknown unicast flooding is so bad, so bad, right? Even in the interview, interviewer is going to ask you this question only from the switching: how to reduce the unknown unicast flooding? And if you know the answer, that means you know the MAC address table. Now you tell me how I can reduce the MAC address unknown unicast flooding. First,
by creating static entry.
second option, by increasing the MAC aging time, right? Either we can create the static entry or we can increase the MAC aging time. If I will increase the MAC aging time, switch will store the MAC address table for longer. And if MAC address is available in the MAC address table, switch will not perform unknown unicast flooding.
And is sticky MAC same as static MAC?
That is port security. That is a separate topic.
Okay.
Previously, you said we in a small company have 4 computers and small switch. We can configure the 4 MAC address in each port statically to reduce the unicast flooding. When the DC that will not make confusion for the switch.
Why it will make confusion, sir?
Yeah, because in every port we put static entry for all for BC.
It doesn't mean it is static or dynamic. Let's say 2 switch are there, switch 1, switch 2. Okay, on the switch number 2 there are 4 PC. PC 1, 2, 3 and 4. MAC address of PC 1A, MAC address of PC 2B, C, D. So switch is going to learn these all MAC address on 0/0 interface A, B, C, D. And here is one PC whose MAC address is P. If this PC is going to send traffic to this machine whose MAC address is A, source MAC will be P, destination MAC will be A. It will forward to switch. Switch will compare destination MAC address with their MAC address table, and it will find that A MAC address is on 0/0. It will forward traffic from here. Similarly, if destination is B, then also it will forward from here. If destination is C, then also it will forward from here. If destination is D, then also it will forward from here. Means these all PCs are accessible from this interface. Why it will create issue, confusion?
No, in this situation we will not create confusion, but the right switch have four PC. In each port I configured the MAC address of the 4 PC in each port.
Sorry, sir.
Is it the right switch?
On
If
this
I
port?
configure, yes, I made the MAC address of those 4 PC statically in this port. And this port and this
on
port.
this port, if you will make entry for A, B, C, D, and on this port also if you will make entry for same
Yeah.
MAC address, then it will definitely create the issue.
Yeah.
If
My
I
question
have configured this MAC address on this port, then I will not create any MAC address from these 4 address on other ports on the same switch. Otherwise, definitely it will create issue.
Yes. Understood. Yes. Thank you, sir.